All right, maybe third time's the charm. I apologize. Again, I don't know what happened, but I got an alert that said the film, there wasn't enough video or something left. I don't know, so I figured I would just start from scratch and go from there. I'm going to try to make this as painless as possible, and I thank you again for being patient. I hope when I go back into the studio and figure out what I should keep and what I should not, hopefully there's not a whole bunch of yelling or, anger. So number 9, page 421 from our ENC pages, we have cosine A, sine E, and DFG. This question does not ask for sides or angles. It asks just for the ratios. And the first one looks a little confusing because it's isosceles and acute. What we have to remember is, thanks for coming back, Natalie, is that we can put an altitude down the middle of this. And in an isosceles triangle, with that altitude, it's also going to become a perpendicular bisector. So what we end up with is 7 and 7 across the bottom. When we look at angle A, and we have our opposite, adjacent, and hypotenuse. Thanks for coming back, Landon. I apologize for the issues. We now have adjacent over hypotenuse, which is going to be 7 over 25. So, hi, Emily. I apologize for all the issues earlier. I taught the entire thing to nobody. So hopefully now you guys can see everything. So we now have this set up. Again, we're only looking for the ratios. So the next one we want to figure out is angle E, and angle E has a completely different diagram, and it's actually an obtuse triangle. Ooh, that's horrible. And we have E, F, D, and out here is actually our altitude at G. And what's nice about that is in the problem, it tells us that's 17, that's 10, and this is 6. So when we work this one out, the one thing that I need to pay attention to is that I have a Pythagorean triple that will allow me to say that that's 8, because this is a 3, 4, 5 right triangle. Thanks for coming back, Irene. Oh, the frustration I've had this morning, so I apologize. Now looking at sine E, we're going to work with this whole big right triangle. And so 8 is actually our opposite side, 17 is our hypotenuse. So when we want to do sine E, 8 over 17 is our answer. Then it switches gears and it asks us to figure out D, F, G. So now we want this reference angle. We still have opposite, adjacent, and hypotenuse here. And because we're dealing with sine, this is now 8 over 10, which means we have to reduce it to 4/5. So keep in mind that when we're looking at a question like this, it just wants the ratios. Now the next question that we were asked about was number 13, same page. And this one had, we want to find tangent of ACD, and we want to find sine A. Now the picture is a bit involved because if we're just seeing it as trig, it's going to be a little bit difficult to figure out because you don't actually have enough values at this point. Now, depending upon how far we choose to work, those of you that want to keep working, those of you that just want to go over past material, again, I said next week we have that option, and the weeks after. But right now, when I look at this question, I have to rely on our old work, which was our altitude on hypotenuse formulas, that geometric mean work. where we had A, B, C, H, X, and Y, and we were able to write our formulas. So A squared was X times C, B squared was Y times C, so adjacent times full hypotenuse, leg squared, adjacent times full hypotenuse, and then hypotenuse squared, or excuse me, altitude squared is equal to part times part. So what we end up with is 3 of our geometric mean, our altitude on hypotenuse formulas, and this is the only one right now that I can solve for. And we find out that X is 12. So if this is 12, this guy has to be 15. And now I have enough to plug in, and I find out that B squared is 45, or B is 9 radical 5. So over here, 9 radical 5. Over here, A squared equals 12 times 15, which is 180. And I end up with A is 6 radical 5. And now I have every value plugged in. And honestly, I could ask any of the trig ratios now for any of the angle measures. Just remember to simplify your radicals. So I'm going to stop there. And I know the question's going to come up. Well, if I'm looking for sine A, do I use this triangle, this right triangle, or do I use the entire right triangle? And I'm going to tell you yes. If you have done this correctly, it doesn't matter, because this angle won't change. It's reflexive. Whether you choose to use the smaller right triangle or the big right triangle, your ratio will reduce to be the same thing. They are similar. So the ratios always will reduce to be the same thing. So kind of keep that in mind. That's why I'm going to let you figure out what the final answer is there. All right, the last question that was asked is actually probably my favorite. And it brings back some stuff that we talked about in our chapter 1, area formulas. So it was number 8, page 426. And the first question was we wanted to find the measure of angle E. The second question was we wanted to find the measure of NOM. The third question is we wanted to find the length of OM. Then part D, we wanted to find the area of triangle NOT, which means we had to do base times height divided by 2. And finally, part E wanted the area of the entire regular pentagon. So we've got all these parts, and in this pentagon, I have to remember that it's regular. I know my drawing doesn't look like it, but we also talked about it does have a center. And when we were talking about a lot of our circumscribe, inscribe, these are actually called radii because a circle could be drawn around it and it would touch exactly at each of those vertices. This altitude that we just drew in this isosceles triangle is also referred to, again, back from chapter 1, as the apothem. So we have some crossover here because we did some things out of order according to this textbook. And this was all the given material. Because it is regular, that means all the sides are 12. We also have to remember that because this is automatically going to be isosceles, that when we have that altitude, it will bisect that side. So I'm just kind of filling in all of the information that I'm supposed to remember from that information. I am going to make a little note that, again, this guy is referred to as the apothem. That's the altitude of that little isosceles triangle stuck inside there. So if I want to find what the measure of angle E is, I have to know what all the angles add up to. And if I don't still have that memorized, that was our formula 180 times n minus 2, which I have it memorized, it's 540. So all the interior angles of a pentagon add up to 540. If it's regular, I take that 540 and divide it by the angles. And I find out that every one of those is 108 degrees. So the measure of angle E is 108 degrees. So all the way around we have 108. Now, the minute these radii are put in, it bisects the angle. So this guy is 54 degrees, and this guy is 54 degrees. I'll zoom in a little bit there so you guys can see. And if that's 54, you know this one has to be 36 degrees. So, when we want to figure out what NOM is, we just figured out that it was 36 degrees. The next part says find OM. Well, OM is this guy. I'm going to use 54 just because it's not as crowded. And I'm going to use my trig functions. Here's opposite, here's adjacent. So what we end up with is tangent. So over here, we're going to do tangent of 54 equals opposite, OM, over adjacent, 6. I'm going to go to my calculator. I'm going to punch in tangent 54, and that's going to copy down a bunch of these decimal places. Again, nothing in particular because I'm leaving it all on my calculator. And thankfully, when I cross multiply, all I have to do is take all those decimal places times 6, and I get about 8.26. So the length of OM is about 8.26. Now that's a good thing, because if I want to figure out what the area of that, just nothing's going good today. I have the 8.26 as the height of that triangle, and all the way across we know is 12. So I don't have to do anything but plug in base times height and divide that by 2. I'll zoom out a minute. There we go. And we find out the area here is about 49.55. So yay, we've got 1, 2, 3, 4 of them finished. It then asks for you to determine what the area of the entire pentagon is. Now I'm going to let you do that one, because what you should be able to tell is that we have 1, 2, 3, 4, 5 of the exact same triangles in there. So if you know the area of one, you should know the area of all of them. What I want to very briefly remind you of is that at the beginning of the year, when we introduced the area formula for a regular polygon. Notice I didn't write pentagon, a regular polygon. So that's any regular polygon. It is area equals A times P divided by 2, or 1/2 A times P. A was the apothem, which we now just saw was that altitude of that isosceles triangle, and P is the perimeter. Of our regular polygon. So what's nice about this is we just figured out that the apothem was 8.26. We had to do trig for it, but we figured it out. Sometimes you might have to do special rights or even the Pythagorean theorem, but we figured it out. We're going to multiply it by perimeter. Well, if each side is 12 and there's 5 sides, that's 60. We're going to then divide that by 2. So we end up with an area of about 247.8. And I don't think it has the dimensions, but if it did, it would be whatever squared. So whatever we found here should be the same, or pretty close to it rounded, to what we find here, doing it essentially the longer way, because we had to find the area of one triangle and then deal with the area of 5 triangles. So it should match. This is just a little bit faster, so you don't have to do all those triangles. So those were the questions that were asked, and I appreciate so much your time. I totally intended on all of this being done well before this, but I suppose seeing as I've now done it twice, you know, that happens. So if you have any other questions, please, please, please email them to me, and I will go ahead and make sure that I answer them. I will tell you right now, I have 2 meetings that I have to attend because, again, I'm senior class advisor, so obviously we've got a lot going on right now. But I have my computer with me. I will have my phone with me. And if you have any questions, I will do my best to answer right away. If not, you will definitely get them back this evening. So thank you for your patience today. I appreciate it immensely. And please continue to check Google Classroom. I will make sure that those are updated and any information is sent there. Thank you all.